Hello, my name is Matt Holliday and welcome back to my class on programming in Go. So in this section I want to take another problem out of the book. It's going to be a homework exercise, but I'm going to work through it. So you can watch the beginning of this video and I'll show you what the problem is, and then if you like you can stop and then pick up again as I work through the solution. Okay, so the problem I want to work on is exercise 4.12 out of the Go programming language book. And the exercise is about going out to a website, getting some JSON, and then processing it. We're actually going to search through it. Okay, so the XKCD cartoon website has a REST API to get metadata about the cartoons, the title, a transcript, the date, and the URL, for example, to the actual cartoon graphic. And it produces data that looks like this. Right, we're going to get some REST data that has the sorts of things I just described in it. So we need to write two programs. The first program is going to go out and download that data. And I'm going to tell you up front, that takes a bit of while. There's now like 2,400 something cartoons. So it takes a while to download all the cartoons. We want to do that once. Get it on disk, and then we'll write a second program to go searching through that for keywords. So if I want to find, for example, this cartoon which describes, someone is sleeping, then I want to be able to put in words like someone, bed, sleeping, and have it find me this cartoon. So on this slide I have an example of what the output looks like, right? There's two programs. The first program will download, so it'll go out there and read and write to a file, for example, until there aren't any new cartoons to pull down. And then the second program is the one that'll search that data, right? And we can search it with different keywords and find cartoons and print out the URL, the date, the title, for example. Okay? And at the bottom of this slide, I have a link to my GitHub repo that has a solution. It's the solution we're going to talk through in this video. So now, if you'd like to try it for yourself again, this would be a good place for you to stop, turn the video off, try to solve it, and then come back and look at my solution and/or, listen to the rest of this video. Okay, so before I get into the code, I want to talk a little bit about what the programs will do. So the first program, I've got a few points on the slide, and the key points are, we're not going to decode the JSON. So we're going to go out there and read this website, and it's going to give us back a JSON object for each cartoon. Now, we can just build up a JSON file on disk then with that, and the approach I want to take, and this will show up in the program, is I'm going to create a file where I start off with an empty square bracket, and then I'm going to get some JSON, and then each time I get the next one, I'm going to put a comma and some JSON, a comma and some JSON, so on. And when I get to the end, I'll just finish it with a closing square bracket. And if I write that in a file, it's basically a big JSON array in a file, where each of the objects in the array is the metadata for one cartoon. And by doing that, I don't really have to decode the JSON at this point. That would be a choice. I mean, the alternative is I could actually decode the JSON, build up a bunch of Go objects, put them in a slice, and then write it out to a file all in one shot. That would be an alternative. But I'm going to take this approach just to show it. Now, for the second program, the searcher, it's going to read in that data. And this time I need to decode it because I actually want to go and search through a bunch of Go objects. So I'm going to read in that big array as a slice of Go objects. That's what it's going to decode to from the JSON. And then I'm going to write a loop that will search it. So on the command line, I expect to get one or more keywords, search terms, right? And we'll have basically, again, and we saw this in another example, a nested loop, because I've got possibly more than one search term, and of course I've got more than one comic. And the logic here will be, I want comics that match all the search terms. Okay, so we'll loop through and look for those, and if they don't match all the search terms, then we'll ignore the comment and move on. Okay. One important thing though is I'm going to simplify this a bit. We're not going to worry about case. So I'll convert the search terms to lowercase, and I'll convert the text inside each cartoon's metadata description into lowercase, and we'll just do a search in lowercase and not worry about case sensitive problems. Okay, so I'm going to move over to VSC again on my laptop because that's going to be the easiest place for me to do this. And I've got the first program, the program that loads. And I've got a little bit of code in here already. So let's just talk about that. I've got some imports that I know I'm going to use. All right, I've got the outline of a function get1. We'll just put a comment there. So it's going to return the metadata for one comic by number. If you give me number 21, I'm going to go out and find the metadata for comic 21. And we'll need to fill that in here in a second. So I have my main program, and again, my main program is going to have some variables. I've already laid them out. All right, and I'm going to do a little bit of argument processing, and I've gone ahead and put that in here also. So I have one of my variables is the output file, okay, and it's going to default to standard out. Now I've written that in a very particular way because standard out, if I go look at it, standard out is actually a type of file pointer. Well, that's very specific, but I want my output to be more generic because I'm going to possibly open some other file. I could open anything. If I wanted to take some of this code and drop it and do a unit test, maybe I want to write to a buffer. So what I'm going to do is I'm going to define this in terms of an interface. And again, we're getting ready real soon to start talking about object-oriented programming in Go, right? But a write closer is an interface of something that has a couple methods, a writer and a closer, which describes files. It may describe other things, but it does describe files. But that's the behavior I need. I want to be able to write to it and possibly close it. Fine. So I'm going to come down here, and if I've got enough arguments, I'm going to take the argument. So I need at least, the first argument, of course, is the program name. Ignore that. So I need one command line argument after the program name, os.args sub1. And if that is given to me, then I'm going to go ahead and create a file, right? I'm going to call os.create. It's going to return me a file. I'm going to put that in output. And if it works, then I'm going to defer closing the output, right? And now this is the value of defer. Remember, defer is function scoped. It won't happen until a function is done, in this case, function main. So I know that my file will close at the end of function main, right? It doesn't close right here at the end of my block, because then it would be closed before I use it. Okay. And now we're going to do some other logic in here. Now, I have some other variables we'll get to, but the first thing I need to do in here, all right, is I need to actually print out my brackets. So I'm going to print out the open bracket. And here's the thing. If I run a loop of some sort and I never get any objects, then I'll just want to print out open and close brackets with nothing else, because that will be an empty array, right? So I need to do that, but I don't want to do it until the end. So I'm going to defer it, right? I'm going to write down the open bracket. I'm going to defer the close bracket. And now my job is to have some sort of loop, right? And I'm just going to tell you the comics are numbered from 1. Okay, so I'm going to have some stopping criteria I'll talk about here in just a second, right? But my comics are numbered from 1, so I'm going to start by going out there and getting comic 1, comic 2, and so on. Now the question is, what's going to be my stopping criterion? Okay, so I could just put a number here. I could say, you know, I less than 1,000 and just get the first 1,000 comics. Or I could know that today there are, I don't know, 2,403 or something comics. I'm not sure what the exact number is, and just stop there, right? But what I want to do is I want to go until I don't get any new ones. So I really want to go until I don't get any 404s, right? If I get a 404, I should stop. Now there's a catch, and the catch is there's an Easter egg in the sequence of comics. There is no comic numbered 404. If you try to get 404, you'll get an HTTP 404 response from their website, right? So I need to be able to skip at least one 404. So I'm going to write this in terms of something else. I'm going to write this in terms of until I get 2 failures, right? And I have a variable up here called fails. So I should probably spell it the same way down here, right? Okay, fails is going to count up every time I don't get a comic, but if I do get a comic, we'll just reset it to 0. So for example, I'm going along and I get, 403, and then I get 404, it fails. And if 405 would fail, then we'd go up another, wouldn't fail twice, but 405 will work, so we'll reset the number of fails back to 0 and we'll keep going, okay? And we'll show how to do that in a second. I also have a variable for error. We'll use that several places. I have a counter just because I want to count how many comics I really got. I'll print that out at the end. Okay, and I have a place to put the actual data I get back. So let's start there, because the first thing I want to do, right, so if I go look at get one, right, get one returns a slice of byte. It's going to go out on the network, and we've seen this, and so writing that code will be easy. It's going to go out on the network, get some bytes from the website, which represent JSON, presumably, right? So I'm just going to come down here, and data is the result of calling get one. Okay, but I'm going to do a little bit more with that, right? Right? If I don't get any data, I'm going to increment my fail counter and continue. In other words, I tried number 404, I didn't get any data, I increment my fails, and now I'll just go on and try 405. Right? And when I get to the end of my sequence, I get to, 2405 or something today, I get nothing. Then I try 2406, I get nothing. Fails will be 2, and we'll just stop. Okay? We won't keep going. All right, so the next thing I need over here is I'm going to need some special logic. And so there's another reason I have a counter, because there's something I have to do, it's just not the first time. And the something I have to do is I have to lay down a comma, right? Because again, if I want to make a valid JSON array, then I need object, comma, right? So, and it's going to be fprint because we're going to write it to output. Okay. And the reason I do it this way, again, right, there's our famous OB1 bug, off by 1, right? I can't just write a comma every time. I can't put a comma before every object or after every object. What I want to do is put a comma before every object after the first one, right? And that way I'll have valid output. Okay, so of course I actually need to write the output. And for that, we'll use our friend io.copy, and we'll write to the output, and we'll wrap our bytes in a new buffer, because that's something that's readable. So we'll just take the data, we'll put it into a new buffer. The buffer then will be something we can copy from. Output is something we can copy to. Not the only way to do it, but this is the way we'll do it. That's pretty straightforward because it does some of the error handling for us, right? We don't have to spend a bunch of time calculating is there buffer space and so on. We can let it do the thinking and just check and see at the end, did it really work or not? It will almost certainly work. So we will almost never take this error condition, but who knows, right? Because if in fact we do have an error, then we're just going to stop. We're just going to quit the program with an error code that says, hey, you know what, it didn't work. All right. So if we get down to the bottom, we actually succeeded. That's the wrong spot. Where's my for loop? So actually all of this should have been inside the for loop. I'm sorry, that is in the wrong place. All right. That goes there. And still inside my for loop, and we'll save this. Here we go. That helps line things up again. Okay. If I get down to the bottom of my for loop, that means I succeeded. I got a comic, I wrote it. So we need to do two things. We need to reset the fails counter back to 0 and increment the count of how many comics we've received. And now our for loop will work correctly. Okay. It's conceivable that I could have written this in terms of I, right? If I is greater than 1, but that assumes that I'm going to get a comic for 1, I'm sorry, right? So by separating the count and I, right, I is just the numbers of comics we're going to attempt to get, and count is the number we actually got, which might not be the same. In fact, it won't be the same because we know we're not going to get 404. Okay, so that's the main loop, all right? That's going to actually copy this stuff out. And the piece we need now is we just need to go ahead and go to the website and read some data. Well, we've done this already in some other code, so that shouldn't be too hard. Actually, we'll make this a variable, so the URL, okay, and the reason we're going to do sprintf in particular is because the number is in the middle, right? So all right, so I get the number of a comic, and it's going to be xkcd.com / the comic number / this magic thing info.0.json, and if I've typed that right, it's going to work. So now we're going to actually go and get it. So response and error are the result of doing an HTTP GET with our URL. And of course, we need if error not equal to nil, do something. And at this point, we're just going to quit. Okay? Because the error would be, hey, we didn't even get to the website. This is not the same as a 404, right? We don't get an error if we got a 404. If we get a 404, we'll get a status code that's not 200 OK. So if there is an error here, we basically are like not connected to the internet or something. And so we'll just stop again. And once again, we'll do an os.exit. Okay. So assuming that we didn't have an error, we have a valid response. And so the first thing we have to do is, in fact, defer closing the body, right? We always want to do that because that's what's going to let the socket hang up. Okay. And now we'll check the response code. So if the response status code is not equal to OK, then we're going to want to do something. Okay, and what we're going to do in this case, first of all, we're going to return nil. Okay, so we are going to return, we're going to keep the program going. We're just going to say, hey, there's no data because we got a 404. But we will print out a message on standard error just so we know that happened. So we'll print out something like skipping a certain number, got a certain status code, right? And we'll print out that status code. All right, so we'll know why we didn't get it. All right, the only thing we expect to get is a 404. And we expect to get a 404 at the end when we start hitting comics that don't exist. Okay, now, what we need to do now is we need to actually get the slice data, the slice of bytes. Okay, so we're again going to turn to our friend ioutil.readall from the body. All right, because that's what we want to return, right? Body is going to be, right, readall is going to give us back a, well, if it gives me the stuff here. All right, for whatever reason, it's being slow to return the GoDoc. But readall is going to give me back a byte slice and an error. We're going to return the byte slice. And so, of course, we need to have one more of these. All right, which that should be very, very weird. If this fails, there's something very weird going on because all we're doing is copying bytes out of the body, right? So we'll just say something like the body is bad and get out. Okay, again, very surprising if that happens, right? So that's our get1 function, right? Our get1 function is going to go out and create the URL with the right number, get it, check the error, defer closing the body, check the status code, and if the status code is not okay, then we'll return nil. Okay, we didn't get a comic, but we didn't have an error in the sense that the actual connection failed. We just said you didn't have a comic. And again, in practice, the only thing we expect to get is a 404. And then we'll check, get the body out. Again, we don't expect this error to happen, but we'll check for it. And then we'll return the body back to the main program, right? Now, the main program is getting back this data, right? So it's getting back a byte slice, all right? And we're just copying it. We're doing a copy of those bytes, right? So it's fine to mix this. We have printfs or print lines up here where we're saying print a character string. And then down here we have something else where we say, hey, just copy the bytes. Again, we expect that they're printable bytes, but it doesn't really matter. We just copy the bytes again to the output stream and we're fine. And when we're done, we'll hit the defer and we'll put the close bracket down and it'll be good. So now I'm not going to run this right now on video. And the reason I'm not going to run it on video is it takes a couple minutes, and I don't want to have us sit here, watching 2 minutes go by. So we're just going to assume for now it's on disk. I ran it, and it produced output like I showed in the slide. So it said, hey, skipping number 404, okay. And then when I ran it, I think it totaled a total of 2,401 comics. So that's how many it laid down on disk. And it's a big file, right? I believe it's right here, okay. So if I do a word count with characters of xkcd.json, right, it's over 2 megabytes of JSON, okay? So that's why it takes a couple minutes. And we're doing it one at a time. We're doing one get at a time to the server. When we do concurrency, we'll see how to make that a lot faster because we'll run multiple gets in parallel and put the results together, okay? But we're not doing that yet. All right, so presumably I've got this file on disk. We now want to work through the second program. All right. And the second program, again, has the function now of searching for things. So let's go take a look. Again, I've got a little bit of code in here already. Okay. I've got the imports I'm going to need. And I've got an example of the JSON because this time we're going to decode it. So here's an example of some of the things in the JSON we're going to look for. And so I built a struct with the struct tags that match that. And this is just my personal preference. When I'm going to decode JSON and I lay down a structure with struct tags, I like to have a comment before it that basically shows an example of what it actually looks like. Right? These are the fields I'm going to take out: the number of the comic, the stuff that will make up the date, the title, and the transcript. And those are both strings. Right? And so then I start my main program, and I've got, again, a little bit of boilerplate code here to read command line arguments. We've done that a lot. So I'm going to say, hey, if I don't have at least 2 arguments, there's something wrong here. Because you need to give me a file to go and read for the JSON. Okay? And if you do, then the first argument, the first command line argument is the file name. All right? And then I'm going to check and say, hey, are there even more than that? Because if you don't give me any search terms, I might as well quit. There's nothing to search for if you don't give me search terms. And maybe os.exit -1 is not the right answer. Maybe I should just say, hey, no search term, and maybe that's just a normal exit. I could put a 0 there, and that would be perfectly okay. All right. Now I have some variables again I've already laid out. The most important one is this slice of xkcd items, right, which is this struct right here that represents one comic. Remember, I put down a JSON file that was basically a big array of objects, and when we decode that, we're going to get a slice of the structure type. Okay. I have the terms, so those are the search terms I'm about to get off the command line. I have an input file, which we'll use here in a second. And then I have the count again, how many did I find, and an error variable. And when I'm done, I'm going to print out how many I found. So I'm going to put all the code in here, right? I need some code in here now to do things like get search terms. Okay. Decode the file and do the search, right? Those are the things that I actually have to put in here. Actually, the way I have this in my example code is decode the file, because if I can't decode the file, nothing else matters, right? So first I have to open it. So I'm going to call another utility function on the file name called os.open. It's going to open the file for reading. And if it fails, we're going to do our usual thing. We're just going to get out of here. And to save time, so I don't have to copy it all over again, write it all over again, I'm sorry, I'll just put something in here. Okay. Bad file or something, whatever. It's going to give me some error message that says, like, that file name does not exist anyway. All right, so we opened the file. I have a valid file in input or some source of input, right? And so now I need to decode it, which really is one step, right? And again, we're going to use JSON new decoder, and the value of that is, because I can just pass it the input, I don't have to read the file into a byte slice and then do something with it, which is good because we know it's going to be a byte slice of more than 2 megabytes, right? So we'll do it this way. And the other thing is, notice I'm passing in pointer to items. Again, we have to give it a reference. We're going to give it a pointer to items. And what is items? It's not one struct. It's a slice of struct. Where is it? Here we go. Right? Items. It's a slice of this struct type. And that's perfectly okay. So what we're telling JSON to decode is a JSON array. It's going to look for an array, and then it's going to create enough of these objects from the data to fill up the slice with the objects that represent what was on disk. Okay? So we've just decoded it in one step. And again, we need to check the error somehow. And actually, I could do it this way. All right. And maybe here I'll just say bad JSON. Fine. So now what I've got is I've got my actual comic data into the program. I opened the file, and then I used JSON new decoder, and then I called decode on it, and so I've got all that, right? So the next thing I need some search terms. And just for grins here, I'm going to print out how many comics I read. So if there's a problem in my code, at least I'll know whether we got it here or later, right? So we're going to make sure we have comics. Just print out, you know, hey, I read this many. All right, and all we have to do is take the length of items, which could be 0 or more. If I never read any, then I wouldn't have gotten an error. If I actually had a pair of empty square brackets, I would get no items, and this would print out 0. And we probably shouldn't continue, all right? But that's fine because we're going to figure that out in a second anyway in our main loop. And then I need to get the search terms. And that's just a matter of doing a range over the remaining arguments, right? So I checked to make sure I had at least 3. So it's okay for me to slice from index 2 on, right? And, you know, the only reason I'm doing it this way is because that gives me an opportunity to modify them on the fly by calling toLower on the term, right? So I'm going to read a search term off the command line, move it to lowercase, and append it to my list of terms. Okay, and now I actually need to do my search. So here's where I start with a couple of for loops. So the first one is going to be over the items, all right? And these structs are not that big, so I'm just not going to worry about the fact that I'm copying it each time. I can live with it, all right? What I need to do is, first of all, I want to create a couple of strings again that are lowercase from the comic. And the reason I'm doing it here is so I only do it once per comic. Right? Every time I read a comic, I'm going to create 2 strings, the title and the transcript in lowercase. All right? So however many search terms I have, I'm only doing the toLower once. Right? And then I'll have another loop inside here over the actual search term. And that's where I'm going to do my searching logic. And of course, the first thing I want to do now, okay, is compare. I've already moved the search terms to lowercase. I did that once when I read them off the command line. Okay, I don't need to do that again. And again, I'm making title and transcript lowercase once for each comic, no matter how many search terms there are. So I'll only do that once per comic. So that's efficient. So now all we really need to do is have this big if statement. And this big if statement is going to say, hey, does this one match? Because if the answer is no, I want to continue. But there's a trick here. And the trick is, I don't want to continue the inner loop over terms. Right? I said my search is going to be the case where if a comic matches all the terms, I want to keep it. So as soon as I find a comic that doesn't, it's time to move on to the next comic. And so I'm going to do that, and we've seen this before. I'm going to put a label on the outer loop so that my inner loop, if it doesn't match, goes and restarts the outer loop on the next comic. And so now I just need my string searching logic, right? If not, strings.contains, all right? Except I need 2 of them because I've got the title and the transcript. I think the The exercise in the book may have said look at the transcript. I just decided to do this with two of them, right? So we're going to check the title and the transcript, and if either one of them matches, that's matching the search term, right? And this one is transcript. Okay, and that still fits on my screen, so I'm not going to do anything fancy with the line breaks here, right? So I'm going to go through the items one comic at a time. I'm going to go through the terms one term at a time. If it doesn't match, I'm done with that comic. Start over with the next comic, right? But it could match if it's in the title or the term. And I've already made these lowercase, so I don't have to worry about case-sensitive matching or anything else, right? So if it works, if it does match, that means I got to the bottom of this outer loop, okay? Right? I got through all the terms matched, so I didn't start over. So anything down here is a success. I'm sorry, I want to put that on standard output. So my error messages and my diagnostic messages are going to standard error, okay? But I actually want to print out a bunch of stuff here. So I'm going to I've already got these numbers, right? So I can do item.num, that was an int. So that will be the value I put in here for the URL for the comic, which takes you to a web page for that comic, which presumably also shows the picture. And then I have month, day, year in American notation. And then finally I have the title. Okay, so I'm going to print out what I showed in the sample. I'm going to print out the URL, I'm going to put out a date string, and I'm going to put out the title of the comic. And if I wanted to, I could actually quote that so it shows up in quote marks. I could do that because this is a printf. Okay, and the other thing I want to do is I want to increment my counter of the number of comics I found, because when we get down to the bottom, I'm going to say, hey, I found X number of comics. All right, and I believe that's the whole program. All right, again, I have the structure I'm decoding into. I open my file and I check that there are command line arguments for search terms. Right, so I actually get the data from the file into a slice of these structures. And if that works, and I get the search terms and lowercase them, so then I have this big loop, which that is a typo, it's items. Okay. Save again, and now I don't have the little red underlining that said you might have a problem there, which is good, right? So I'm going to loop over the comics, and then I'm going to loop over the terms. I'm going to find ones that don't match and skip, and then I'm going to print out the ones that do match and count them, and finally say how many I found. Okay, and so now I should be in a position to actually run this. Okay, and if I go here and type I believe I put it in the find subdirectory. Okay, and I need to give it the name of the file, which is the xkcd.json. And I'll give it some search terms, someone, bed, sleep. Okay, and it went through 2,400 comics instantly. It read them in, searched through them, and came back and said, yes, we found number 571 from 4/20/2009 with the title Can't Sleep, which is the one that I actually put in the picture in the slides. Now, what if I take out one of those names? What if I take out sleep? Okay, and the answer is it went and found 10 comics, right? So the combination of the word someone and bed found a whole bunch more. And here are their numbers down here, okay? And interestingly enough, if I do a command click, we will open the external website, and here it is. Let me blow that up, right? That is number 1529, which is this one down here. I didn't know I could do that, so I can command click and go to a URL directly out of VSC. Okay, so that's our answer for exercise 4.12. It said download the comics and write a program to search them, and to download we also wrote a program. So we have one that went out to the web, and it took a long time. It took me about 2 minutes and 15 seconds to run it and get the file. But then when I search through it, that's instantaneous. So all that time was doing all those HTTP GETs one after another at the REST API. And I probably could have made that run a lot faster by doing them in parallel, and we'll talk about that later when we get to concurrency.